Hello children, welcome back to my channel. I'm doing 10th class SSC physics, and in that first lesson, reflection of light at curved surfaces, that is mirror, reflection of light in curved mirrors I've been doing. I have completed 2 marks questions and now I'm doing 4 marks questions. In this 4 marks question, the first question is the magnification of the image by a concave mirror is -1. Mention the mention the 4 characteristics of the image from the above information. What is this? Magnification of the image by a concave mirror is -1. So actually magnification is -1 means what? Magnification is -1 means, first magnification is 1 means the object size and image size will be one and the same. So magnification is 1 means what? It means size of the object and size of the image are same. You should know this meaning, children. 1 in the sense size of the object and size of the image is same. And what is -1 means? -1 means the image is inverted. It is an inverted image. And the question is, see, when you are drawing ray diagrams for a concave mirror, if you take this is principal axis, this is focal point, and this is center of curvature. So when an object is placed at C, a line parallel, it goes to the mirror. This is concave mirror, and it passes through principal focus like this. And another line, incident ray, it passes through focus like this, and it crosses it like this, and it goes. This is a reflected ray. These two, when you join, you will be getting image. So only when the object is at C, the image object is at C, image is also at C, and also the size will be of the same. That is why when you are saying magnification is 1 in the sense what? The image formed is having same size as that of the object. And minus, this minus indicates that the image is inverted. If the object is erected, if this is the object, then this is the image. Image will be inverted. Only in this case, we are considering the negative sign. So that is the meaning for this question, children. The magnification of the image formed by a concave mirror is -1. Mention the 4 characteristics of the image from the above information. So the answer is like this, you see, children. Magnification of the image is -1. This means the size of the image and the size of the object is same. And this is possible only when the object and image are at the center of curvature. This is what I have shown you here, children. See, only when the object is at center of curvature, then only the object and image both will be having same size. In other cases, it is impossible, children. Okay. So, what are the characteristics? They are asking the characteristics of the image. The characteristics of the image is the size of the image and the object are same, and the image is formed at C. It is an inverted image and it is a real image. These are the 4 characteristics. I hope I am clear, children, and I hope you have understood this. Only the thing, the size of the object will be same as that of the image only when it forms at C, and it is an inverted image we are getting, and it is a real image. This is first question, children. Now let us see the second question, children. The focal length of a huge concave mirror is 120 centimeters. A man standing in front of it at a distance of 40 centimeters. A man is standing at a distance of 40 centimeters. So the question is, what are the characteristics of his image? So let us first have an idea about the diagram. See, there is a huge concave mirror, they said. Huge concave mirror means it will be having focal length, very high focal length. How much they said? 120 centimeters is the focal length. Now this is pole. The person is standing at 40 centimeters. Somewhere here the person is standing. So if this is F, then somewhere here you will be getting C. Now, if you draw a ray diagram, first what you will do? You will have to draw a ray diagram passing through C. So this is incident ray. This itself is a reflected ray. Sorry, it itself is a reflected ray. We know that, and we know that another ray, which is passing like this incident ray, it gets reflected through principal focus like this. Through principal focus. These two rays, when you extend them further, these two rays meet at a point. This is the image formed. This image is also should be drawn in broken line. This is the image that is formed here, children, on extending these lines. So what is the image that is formed? It is an erected image, it is a magnified image, it is a virtual image. This is what we have to do. It means we should have a clear-cut idea, children. The focal length is 120 centimeters. Person is standing at 40 centimeters from the mirror means what? His distance is between P and F. We know whenever an object is between P and F, you will be getting a virtual image, an erected image on the other side of the mirror. So this is what we need to write. So that is what is written here. You see, focal length of the mirror is 120 centimeters. A man is standing at 40 centimeters. So the object lies between pole and focal length. Hence, the image formed is virtual image, erected image, enlarged image, and the image is formed behind the mirror. These are the characteristics. Children, please note it down. Now the third question is, how can you find out the focal length of concave mirror experimentally when there is no sunlight? Usually when sunlight is there, you can focus mirror to the sunlight and you can get the image. The question here is, when there is no sunlight, how can you get? So for this, your answer is, first fix a concave mirror to the holder. What is the holder, children? See in this figure. This is called as holder. This is a V-shaped groove will be there for this wooden block into which you can keep the mirror. So this is called holder of the mirror. So first point is what? Fix a concave mirror to the holder. Next, keep the holder on the table. See, this is on the table, you have to keep the holder. Next, keep a candle in front of the mirror. See, this is mirror. In front of the mirror, a candle is placed as the source of the light because there is no sunlight. Next, keep a screen to catch the image of the candle. So see, children, this is the screen. This screen is placed in front of the mirror. So what for? To catch the image of this candle. Okay. Then adjust the screen to get the clear image of the candle. What you have to do, this screen is there now. You have to move little bit front, back. As you are moving, you will see the image. But a clear cut, sharp image you will be finding at only one point. So you have to adjust the screen in such a way that you will be getting a clear image of the candle. That measure the object distance u and measure the image distance v. See children, the scale that is there here, with this you can measure what is the object distance, means from the mirror to this place. By using the scale, you can measure how many centimeters away the object is there. Object distance is considered as u. Now measure the image distance, means the distance from the screen to the mirror. If you measure this distance, this is v. This distance is v. Determine the value of v at various positions of u. See children, suppose, see, in this image, object mirror is placed at 0 and object, that is candle, is placed at 14 centimeters. You take it out, keep it at 12 centimeters. Adjust this screen and get a clear cut image. Again, put it at 10 centimeters. Adjust the screen. Again, you get an image. Where you are getting image, there the distance you have to measure, that is V. Like this, few trials you have to do. So to get different values of V at various positions of U. Then substitute the values in the mirror formula. 1 by f is equal to 1 by u plus 1 by v. For every step, at 14 centimeters when the candle is placed, what is its v value? At 11 centimeters or 10 centimeters when the candle is placed, what is its value? All those different values of u and v you have to take, and you should calculate. You know how to calculate rational number addition, you have learned in your mathematical classes, so you know how it has to be done. So suppose you have taken 5 various positions of u, you will be getting 5 values for it. So actually you can even do it like this children. 1 by f, mirror formula is what? Mirror formula is 1 by f is equal to 1 by u. Mirror formula is 1 by f is equal to 1 by u plus 1 by v. Actually this means what children? LCM if you take, it is uv. 1 minute. So 1 by f is equal to 1 by u plus 1 by v. LCM if you take, it is uv. So you know that v plus u. What is that? 1 by f is equal to. So what is f children? F is nothing but uv by u plus v. This is the formula which you can use. This and this one and the same children, don't get confused. So you want f means f is equal to uv by u plus v. What is u? U is object distance. And what is v? V is image distance which you are measuring by using the scale. So these values if you substitute, you will be getting various values. So when you are taking f values at various positions, 1, 2, 3, 4, suppose you have done f value for different positions, you are getting some values of f by using the formula uv by u plus v at 14 centimeters, at 10 centimeters, at 8 centimeters, at 6 centimeters, like that you can find out, you can determine. After finding out these values, substitute the values in mirror formula, find the average of f values obtained. See, so many f values you are getting 4. So if you want average, how you will rate? See, let me talk it. It's F1, F2, F3, F4. So how will you find average? F1 plus F2 plus F3 plus F4 values divided by 4. So if you do this, you are going to get one F value. F is equal to something. You are going to get F value. You are supposed to take this, children. Usually in science, whenever you are performing experiments, mainly in physics, with calculations when you do, that experiment should be done for 3-4 times. Same experiment should be repeated. Why? To get rid of parallax error. What is this parallax error, children? See, suppose you take a scale and measure, see its measurement. Suppose 10 centimeters you wanted to see. If you see it straightly, you will get one value. If you take a turn, it gets the angle of the vision will make the value or the particular measurement to move little bit right and left. So to get rid of this is called, what do you call? This is called as parallax error. To get rid of this parallax error, this average is done. So that point also should be written in the examination so that the examiner will have a very good opinion about you, that you know perfectly well about how the experiments have to be conducted. So find the average of F value. Find Find the average value, F value obtained. By this method, focal length of the mirror can be obtained. So you have to write these points and you should draw this diagrams, children. This diagram is very important. Draw this diagram and write those points. This is for 4 marks. In case for 6 months, sometimes they will ask what are the materials used for this experiment and how this experiment has to be performed. You can use what is the aim of this experiment. Aim is to determine the focal length of a concave mirror and what are the materials required. Here materials required means what you will write: a concave mirror, a stand, a V-shaped stand, and a candle, and this one is a screen, a scale. And of course, this all should be kept up on a paper, a sheet, so that you can note the values very clearly. So these are all the requirements. In case if you get that question, what are the materials required, you have to write that, children. At present, for this question, these points if you write and you write this, quite enough, you will be getting full marks, children. I hope I am clear. You have only these 3 questions in 4 marks. Next, we have objectives here. Let us discuss the remaining part in the next class.